So, what do I mean by best, average, and worst case complexity each time? So, best case algorithm refers to minimal operations. The average case refers to the expected performance across all inputs. Then there is the worst case performance where the maximum operations are performed. So, insertion sort has best case as O of n and worst case as O of n square. So, average case means some reasonable number of inputs. Worst case means maximum number of inputs, and best case means some minimum number of inputs. Then we also have the graphical comparison. Like for example, if you have O of n, the next higher complexity is O of log n, the next higher complexity is O of n, the next higher complexity is O of n log n, the next higher complexity is O of n square, O of 2 power n. Like this we get the complexities. Steeper curves indicate poor scalability. So let's say um, if I take n means it is one n indicates some linearity. Then if I have n square, then if I have with n square, what will I get? Let's say is if n is 4, then I'll get 4 square, that will give me 16. So here, wherever I have steeper curves, that means the complexity is, that is the number of steps is rapidly increasing, then in that case it will give me poor scalability. Usually if I have logarithmic, linear algorithm and linear algorithms, they are the most efficient. So a combination of which is linear logarithmic, that also gives me a good, probably good efficiency. Exponential complexity is rarely acceptable. So I'll have O of 1 which is constant time, O of log n which is logarithmic, O of n which is linear, O of n square, quadratic, this is called as quadratic. Like for example, accessing one array index is O of 1, binary search is O of log n complexity, linear search is O of n, bubble sort is O of n square. When it comes to space complexities, constant space will be O of 1. Like let's say if I want to put something in an additional n space, then it is O of n. If I have recursive calls, they will use additional space of O of n. So if I have non-recursive algorithm and consider I only want to use uh, factorial using a loop, I want to calculate factorial using a loop. Now time complexity is O of n, but space complexity is O of 1, because I'm not going to make any extra space. I'm not going to make use of extra space. If I have an algorithm, a recursive algorithm, that is recursive factorial to do the same thing, then the time complexity is O of n. The space complexity is also O of n, because whenever I'm making a function call, a stack space is required. This can cause stack overflow. And so I should make use of tail call optimization here whenever possible.